All right, so here I'm going to present the solution from EDC's programmable flow product and how it can define a new type of virtualized network on top of a physical open flow switches, a network of switches. So I think we all are aware of all the problems. Just to recap, of the problems mentioned by Igor and others also before in the talk. But what we are seeing is that we have a performance scaling problems because of the new modern generation of data center networks where you have a lot of HPC operations going on with east and west traffic, and you need a lot of end-to-end bandwidth. And what happens is that because of the structure of the network, you may not be able to get that bandwidth across the data centers. You may not be able to move the VMs to get more resource utilizations. And these are all connected to the current legacy network with sort of constraints, how the VMs can be moved around, or how the network can provide a set of paths to add into the bandwidth, or even in terms of the reliability. Not only the problem is in the scaling, there's also problems in the complexities. As new protocols comes up, you have to learn the protocols, you have to ensure that the vendors support these protocols. You have to go by all the switch and the port configurations, and each time the network is increasing, you have to think about how to take care of all this configuration, what type of scripts you have to build. And it's not just limited to the configuration, even the architecture of the design of the protocols, it becomes a more task to become specialized in these protocols and the network architecture, how it depends on the protocols in applying some sort of optimizations required by the end applications. Not only that, with the use of the more virtual appliances nowadays coming in the cloud networks, it becomes a difficulty also in how you integrate these appliances, how you bring in on-demand appliances into the whole area. So the complexities are adding up slow and slow, and it leads to difficulty in automation because you do not have a very nice homogeneous view or a streamlined view of what the network needs and how to go and program it. And the question we are raising is that, does network virtualization help, and does OpenFlow provides a better framework to do such network virtualization? So what would we need for such network virtualization? What would be the basic principles which should guide some of the characteristics of network virtualization? We all know that network virtualization has been thought through in different contexts. There can be node-level virtualization of the same function in a router framework, or even a VLAN is a type of virtualization. So what is the new part here? What we are trying to say here is that if you consider a modern data center network, which is like very structured type of switching network, supporting that, then why not we consider that whole set of switches as like separable pool of resources, and then aggregate them as a pool, and then define as if like there is one single switch, or one single virtual switch, or one single virtual network. And the reason to do that is that to sort of hide all the complexities which are there in managing the switches and the connectivities and increase and decrease in the number of elements, but to hide them and to provide a very simple type of exposition to the operation side, so that he can only think about the logical part of the network, the functionality part of the network, as opposed to how many switches are there, how to connect it, how to run protocols in that. And why is it doable in the OpenFlow world? It's because that in the OpenFlow case, each switch is managed individually by a controller. So you are taking out all the control plane which are coupling the switches. And once you take out the coupling, then you are having separable resources which you can combine as you want it. And that is where you have the opportunity to define some sort of end-to-end network virtualization as opposed to a switch virtualization, path virtualization, but considering the whole network as one single logical infrastructure. So what does it mean? I mean, to go very fast into specific things is that, for example, you can create a definition of a virtual network onto the completely virtual network world, where you can define things like virtual bridges, virtual routers, and externals, and the links also, without even having to know what is there underlying the physical network. It looks like a complete new way of looking at it, but it's so simple from an operator side that he be differentiated from the person who is actually managing or plumbing the network. He is more considered about the business of it, of the logic of it. He's just focused into the virtual network domain. He goes and creates his own network and then let the whole controller, let the whole open flow technology to go and deploy that into the actual physical network. So he doesn't have to worry about what switch I go, what forwarding table I have to go and put, when do I have to put it, how do I patch these forwarding tables to give me the path end to end. He just worries about only his own requirements and then push it into the virtual network. Of course, the virtual network has to be rich in its interface so that it sort of encompasses all the type of requirements. And this is a good start, and one thing we're trying to build is that how that becomes a rich framework. But it is that framework which makes the most important thing is that it not only hides the topology details, the protocols and everything, it also zeroes down the entire switch and port level configurations in the deployment, because that might change. But the virtual network, which just resembles or corresponds to the real requirements, doesn't change usually. And what it also allows is that when you think about a network, you have discussion of reliability, performance, multipath, all these things. It's not really something required from the one who wants just a function. He just wants the function to be there and let the whole optimization be automated in the whole process. And that can be done as a sort of a part of the new features being added by the network. The other important part in a case of a virtual network is that, just like very much similar to the server scenario, once you virtualize, you have the opportunity to create this concept of multiple virtual networks. Not just like you have one single network which you now see, which sort of like tries to sum up all the requirements and tries to cater to all the needs under the same policy, same routing and the forwarding table scenario. Here, if you have, let's say, a physical network, and then what you can do is you can create a virtual network, just a layer 2 network, and then you can deploy it into the same physical network. You can go ahead and create another network, which can be a layer 3 network for your requirement, and you can deploy on the same physical network. There are multiple good things about it. One is that it can be a staging network, and the one who's designed a staging network doesn't have to worry about what the real operational network is going to get screwed by whatever he is defining in that. You can isolate it based on like maybe wanting to create it for a Hadoop network, one which has a more east-west traffic, maybe something in a more email server network. And these things allows different operation team to go and focus on its own virtual network without having to worry about what the other virtual network operator is doing. Of course, there are many other use cases for that, but it sort of embodies the same principles which is used also in the server virtualization world. The next part is all about optimization. One is about how I can operate the network, how I can define, how it can be nicely isolated so my management is easy. The second is the optimization of the network. And the part of this is that you can define the virtual network, let's say consider of a virtual network layer 2. Now what happens is that since there's a fine-grained control from the OpenFlow to create a path, so you can let the controller compute the path and create all the multiple paths without having to know to the end user or the operator that how it is doing. And the good part is that here you can not only discover multiple paths when a new switch is added or a new link is added, you can also avoid the loops because you have a complete topology understanding of the whole network. You can also balance the flows into the network without any flapping because everything is centralized. So these are some of the advantages you're trying to get when you are running a centralized way of doing it. And just if you remember the part which Nick said in the morning, that half of the things are very small route computation where the entire distributed protocol part is essentially sort of avoided when you're doing that as opposed to a normal legacy network. Comes the question of even the reliability part. You're able to provide end-to-end reliability, where if any point, any link, any switch dies in the entire network, you're able to detect it and you're able to compute the path, recompute the path in the end-to-end level. And you're able to do that fast because there's no convergence, which you typically see in a distributed protocol. And because there's no convergence, you're able to do it fast, like we see around like 200 to 400 milliseconds. You can detect and you can create end-to-end path and even switch the flows into the new path and get the whole system running. This is just like a high-level virtualization of how the system works. You basically can have switches from any vendors. You just have a network virtualization plane, which can be defined by using an OpenFlow controller with a virtual stack on that, and you can have like a mix and match of any switches. It can be a 1 gig switch in the end or a 10 gig switch in the core, and any combination of that is automatically being managed by the whole system. The virtual stack, which is what defines all this thing, is built on top of an OpenFlow controller. There's an important part is that it is a network knowledge plane which is continuously gathering the information of the topology to get a whole topology understanding of the state on a continuous basis, because that's how you are able to sort of do end-to-end routing and have a network level virtualization. On top of it is the multiple tenant virtualization. So if one tenant is writing his own policies and rules, it doesn't conflict with others. So there's someone who goes into the level of model checking, level of ensuring that when you deploy, there is no conflict among the tenants. And what it opens up in the top is essentially bridges, routers, and links, and to create your network. Finally, what happens is when you create that, it is translated to the OpenFlow in a dynamic basis, which then goes and programs the switches as it wants. So these are some of the benefits, the complexities. You're able to automate through APIs, you're able to do end-to-end reliability and all the things which people want to talk about. So that's one of all the benefits, summary of the benefits of the virtualization. And I have just one last thing which you can also do that sort of takes all the things away from the legacy network. It's not about the same layer 2 and layer 3. Can we do something more? And that's what we define as a conditional routing. So in normal routing, you have a destination and the packet is forwarded based on destination, whether it's a layer 2 and layer 3. What about, I don't want to do that. My ways would be that, I want to define a condition, and that condition has to connect to a particular destination and should route it to that. Is there some application for that? Does it create a lot of rich framework to do many things which you're not able to do in the legacy? I leave it open, to people to think about it, but I can give you some examples. One is here that, take a simple case of a firewall. A packet is coming from an internet to the server, and I can create a condition for those packets. I want to take it to this firewall. Maybe that's a special anti-spamming firewall. Or I can create a much more complex network. I can create composing all these conditional things. Like I want, in a packet which is coming to a particular destination, I want first to take it to a firewall, and then I want to take it to a maybe intrusion prevention system, and then I want to take it to the server. Now, is it easy to do it in the legacy, or can these type of frameworks make it much easier to define in the modern world of where you want to compose different appliances and steer the routes as you want it? So these are some of the functionalities which you're able to do by simple constructs of filters and redirects and bridges using only the virtual world without even having to worry about what there is in the physical world. That's it. Thank you very much.